All right, so 3.4 goes over your rational zeros theorems. With this, we're going to be solving these expressions or equations for what our variable is equal to. When you do these, you can use synthetic division. Whenever you do that to start, I would use it if your first term has a power greater than 2. So like in this, bless you, this example, you have p of x is equal to x cubed minus 3x plus 2. So because that x cubed is there, it's a power greater than 2, I'm going to use synthetic division. When I use synthetic division, I want to find the factors of my constant within that expression. So if I look here, my constant is the 2. My factors of 2 are positive and negative 1 as well as positive and negative 2. I can start by using the 1, using synthetic division. So remember, with synthetic division, you want your coefficients of your numbers as well as every single term represented. So you have an x cubed, that coefficient there is just 1. You do not have an x squared there, so that coefficient would be 0. Then you have x, which has a coefficient of negative 3. And then you have the constant of 2. All of those go down. Your first term you're going to bring down, that's the 1. Multiply the 1 with the 1 in the box, you get 1. Add the 0 and the 1, you get 1. Do it again. 1 times 1 is 1. Put it underneath the negative 3, add them. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Add that with the 2, you get 0. Because you get 0 here, that 1 is a solution. So you have x is equal to 1. Remember, this 0 is your remainder. Then the negative 2 is your constant, making the x a 1 and the x squared a 1. So this is going to give you f of x is equal to x squared plus x minus 2. Now, if you can solve this by factoring because you have the x squared, you do that. So you have a negative 2, the factors of negative 2 that add up to be a 1, that's the coefficient of that x term. You have a negative 1 and a positive 2 give you that 1. So we're going to factor this out to be x minus 1 times x plus 2 is equal to 0. You want to set each set of parentheses equal to 0, so x minus 1 is equal to 0, x plus 2 is equal to 0. And then solve for each of these. So add the 1, you get that x is equal to 1. Subtract the 2, you get that x is equal to negative 2. So ultimately, you have the x is equal to 1, the x is equal to 1, and the x is equal to negative 2. So you would give all of these as your answers. So x is equal to 1, x is equal to 1, and x is equal to negative 2. Now, I understand that you have that x is equal to 1 more than one time. This is where your multiplicity comes into play. So multiplicity is when that number occurs more than once for an answer. So this would have a multiplicity of 2 at x is equal to 1, and then just x is equal to negative 2 as well. Now, when you find these zeros, meaning your answers to what x is equal to, you can set up your polynomial as a multiplication problem of binomials. This just means you're going to take each of these, that x is equal to 1 gives you x minus 1. That x is equal to 1 gives you x minus 1. And that x is equal to negative 2 gives you x plus 2. So you're going to take the opposite of the number and put it in parentheses with x. So this is also p of x is equal to x minus 1 times x minus 1 times x plus 2. So you want both of these, or you want to know how to get both of these for this, because you will be asked to get both your answers, so the zeros as well as the factored form of the given expression. Next page in your notes literally just gives you an explanation of what we just did. So we're going to look at more examples and do the first one here that you see, this f of x is equal to x to the 4th power plus x cubed minus 6x squared minus 4x plus 8. So again, I have a power greater than 2 So I'm going to start by using synthetic division. First thing I'm going to do is find my factors of my constant. My constant is 8. So I have a plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So I could try each of these 8 numbers using synthetic division. If I get a remainder of 0, I know that's a solution. So I'm going to start with a 1. I have my coefficients of 1, 1, negative 6, negative 4, and 8. So I bring down the 1. 1 times 1 is 1. I add those, I get 2. 2 times 1 is 2. I add those, I get negative 4. Negative 4 times 1 is negative 4. I add those, I get negative 8. Negative 8 times 1 is negative 8. I add those, I get 0. I have a remainder of 0 here, so I know that that 1 is a solution. So I circle it and I make sure I highlight it or something so I remember that's one of my solutions. Now I have to find a new polynomial with what I got using my synthetic division. So that negative 8, that negative 4, the 2, and the 1 are all coefficients of a polynomial. Starting with that 0 as a remainder, the negative 8 would be your constant. That negative 4 is going to have an x. 2 is going to be the x squared. And 1 is going to be x cubed. So this just gives us f of x is equal to x cubed plus 2x squared minus 4x minus 8. So once again, I'm going to use synthetic division because I have a power that starts this polynomial that's greater than 2. So my factors of negative 8, again, are the 1, the 2, the 4, and the 8. So I can try 1 to start with. I'm going to use my coefficients from this polynomial, this 1, 2, negative 4, negative 8. I pull down that 1. 1 times 1 is 1. Add those, I get 3. 3 times 1 is 3. Add them, you get negative 1. Negative 1 times negative 1, or sorry, negative 1 times 1 is negative 1. So I add those, I get negative 9. This negative 9 is not a remainder of 0, so this 1 does not work as a solution. Try another number. Let's say I try negative 1. I still have the 1, the 2, the negative 4, and the negative 8. So the 1 drops down. 1 times negative 1 is negative 1. I add those, I get 1. 1 times negative 1 again is negative 1. I add those, I get negative 5. Negative 5 times negative 1 is a positive 5. I add those, I get negative 3. Again, not a 0, so the negative 1 does not work. Next, I'm going to try 2. So if I try 2, I still have 1, 2, negative 4, negative 8. The 1 drops down. 1 times 2 is 2. I add those, I get 4. 4 times 2 is 8. I add those, I get 4. 4 times 2 is 8. I add those, I get 0. Finally, I have a 0 as a remainder, so that 2 is a solution as well. So far I have the 1 and the 2 that are solutions. If I rewrite this polynomial using my answers at 1, 4, 4, and 0, the 0 is my remainder, 4 is my constant, the next 4 is going to have an x, the 1 is going to be an x squared. So this gives us f of x is equal to x squared plus 4x plus 4. Now, I do have an x squared here, so I can ask myself if I can factor this by finding the factors of 4 that add up to be 4. My factors of 4 that add up to be 4 are 2 and 2. Oops. So this is going to factor out to be x plus 2 times x plus 2. I set it equal to 0, so I know that I'm solving for x. And I'm going to set each set of parentheses equal to 0. So I have x plus 2 is equal to 0, as well as x plus 2 is equal to 0. We're going to subtract 2 from each side, so x is equal to negative 2. Do the same thing with the other, and x is equal to negative 2. So my answers here, I have x is equal to negative 2, x is equal to negative 2, x is equal to 2, and x is equal to 1. So x is equal to 1, x is equal to 2, x is equal to negative 2, x is equal to negative 2. So all of these are solutions. And to write this in factored form, we're going to have this x is equal to 1 is going to be x minus 1, x is equal to 2, x minus 2, x is equal to negative 2 is x plus 2, x is equal to negative 2 is x plus 2. So if we put all of this together, we would just have f of x is equal to x minus 1 times x minus 2 times x plus 2 times x plus 2. So my zeros here are the 1, 2, negative 2, and negative 2. If I wanted to say that I have a multiplicity of 2 at negative 2, I could do that as well. And then factored out, we just have f of x is equal to x minus 1 times x minus 2 times x plus 2 times x plus 2. For example 2, we have g of x is equal to x cubed plus 5x squared minus 2x minus 24. So first thing I'm going to do, I realize I have a 3, not a 2, as a power. So I'm going to find the factors of that negative 24 that I can use with synthetic division. So my negative 24, I have factors of positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 8, positive negative 12, and positive and negative 24. So let's say I start with 1. My coefficients of that polynomial that I'm starting with are 1, 5, negative 2, negative 24. So I'm going to drop down the 1. 1 times 1 is 1. Add that with the 5, I get 6. 6 times 1 is 6. Add that with the negative 2, I get 4. 4 times 1 is 4. Add that with the negative 24, I get negative 20. Once again, I do not have a 0 as a remainder, so that 1 is not a solution. Next, I'm going to try negative 1. I have 1, 5, negative 2, negative 24 as my coefficients. I drop down the 1. I get 1 times negative 1 is negative 1. Add that with the 5, I get negative 4. I'm sorry, a positive 4, not negative. 4 times negative 1 is negative 4. Negative 4 minus 2 is negative 6. Negative 6 times negative 1 is a positive 6. Add that with the negative 24, it gives us a negative 18. This one does not give us a remainder of 0, so negative 1 is not a solution. Next, I'm going to try 2. I have 1, 5, negative 2, negative 24. The 1 drops down. 1 times 2 is 2. Add that with the 5, gives me 7. 7 times 2 is 14. Add that with the negative 2 is 12. 12 times 2 is 24. Add that with the negative 24, that gives me 0. That's a remainder of 0, so that 2 is a solution. If I form my next polynomial with the solution of this synthetic division, I have a remainder of 0, a constant of 12, an x of 7, and an x squared of 1. So this is going to give us f of x, or g of x, doesn't matter, is equal to x squared plus 7x plus 12. Now I'm going to find my factors of 12 that add up to be 7. 3 times 4 is 12, and 3 plus 4 is 7. So my factors here are going to give me x plus 3 times x plus 4 is equal to 0. I set each of these equal to 0, so x plus 3 is equal to 0, x plus 4 is equal to 0. And now I solve. So I subtract the 3 from each side. I get x is equal to negative 3. I subtract the 4 from each side. We get that x is equal to negative 4. So our zeros here are the x is equal to negative 4, x is equal to negative 3, and x is equal to 2. So these are our zeros. If we write this as a product of binomials, or product of its factors, we have x minus 2, x plus 3, and x plus 4. So this is just g of x is equal to x minus 2 times x plus 3 times x plus 4. For example 3, we have h of x is equal to x cubed minus 12x squared plus 47x minus 60. So the first thing you want to do here is find the factors of the negative 60. This gives you the possible solutions here. So all possible factors that you could use for that negative 60 would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Yes. Plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 20, plus or minus 30, and plus or minus 60. So all of these, if you had a question on a quiz or a test that asks you for all possible factors, these are all of the numbers that you would give, okay? From here, choose some of them. Use synthetic division because you have a power greater than 2. You have that x cubed, so we're going to use synthetic division here. So I'm going to start with 1. My coefficients from 3, my power of 3 to my power of 0 are 1, negative 12, 47, and negative 60. I'm going to drop down that first term. I have a 1. 1 times 1 is 1. I add that to the negative 12. I get negative 11. Negative 11 times 1 is negative 11. I add that to the 47. We get 36. 36 times 1 is 36. I add that to the negative 60. It's going to give me a negative 24. This does not give you a remainder of 0, so that 1 is not a solution. Try negative 1. We still have 1, negative 12, 47, and negative 60. So I drop down the 1. 1 times negative 1 is negative 1. That gives me a negative 13. Negative 13 times 1 is 13. I add that with the 47. That gives us 60. 60 times negative 1. Hold on. Negative 13 times 1 is, yes, 47 plus 13 is 60. 60 times negative 1 is negative 60. This gives me a negative 120. That one doesn't give us a remainder of 0, so that doesn't work. Next, we'll try 2. So we still have 1, negative 12, 47, negative 60. The 1 drops down. 1 times 2 is 2. Add that, we get negative 10. Negative 10 times 2 is negative 20. We add that, we get 27. 27 times 2 gives us 54. We add that, and we get negative 6. Again, not a 0 that we're looking for. 2 doesn't work. Try negative 2. We have 1, negative 12, 47, negative 60. The 1 drops down. 1 times negative 2, negative 2. It gives us a negative 14. Times negative 2 gives us 28. We add that with the 47. It gives us 75. 75 times 2, or negative 2, is negative 150. We add that with the negative 60, gives us negative 210. Again, not a remainder of 0. That doesn't work. So let's try 3. We have 1, negative 12, 47, negative 60. 1 drops down. 1 times 3 is 3. Add that, that gives us negative 9. Negative 9 times 3 is negative 27. Add that, that gives us 20. 20 times 3 is 60. Add that, we have 0. Finally, we have a remainder of 0. So 3 is a solution. From here, if that 0 is our remainder, the 20 is our constant, the negative 9 has our x, and the 1 has our x squared. So this is x squared minus 9x plus 20. We set it equal to 0. Because we have a variable that has a power of 2, we can solve this by factoring now. So find the factors of 20 that add up to be negative 9. Well, negative 4 times negative 5 is positive 20. Negative 4 minus 5, or negative 4 plus negative 5, is a negative 9. So this factors out to be x minus 4 times x minus 5. We're going to set both of these equal to 0. And we're going to solve for x. So we add the 4. Oops. We get that x is equal to 4. We add the 5. We get that x is equal to 5. So x is equal to 5, x is equal to 4, x is equal to 3. So these are our zeros. If we were to write this as a product of binomials, this x is equal to 3 is going to give us x minus 3. X is equal to 4 gave us x minus 4. And x is equal to 5 gave us x minus 5. So we write this all together, and we have x minus 3 times x minus 4 times x minus 5. So some of these take a long time in order to find that factor when you're using synthetic division. Some of them don't. It just depends on the numbers you choose. Again, you don't have to choose 1, then -1, 2, then -2. You could have chosen 3 to begin with and gotten that first number that is a solution. You could have also chosen 4 or 5 first, besides doing all of the work that we did, and gotten a solution. It's totally up to you which number you choose to pick. If you pick the right one first, that's great. You don't have to do everything else.